For decades, Pluto has remained a frozen whisper at the edge of our solar system, a world of twilight and silence, a place so far away that sunlight takes more than 5 hours just to reach it. Once it was a mystery too distant to care about, a forgotten outpost in the cold. But that changed in 2015, when NASA's New Horizons spacecraft arrived. For the first time in human history, we saw Pluto not as a dot of light, but as a world. A world of ice mountains, nitrogen plains, and skies faintly glowing blue. The images stunned scientists, yet hidden within that data was something they couldn't explain, something NASA quietly left unresolved. Pluto was too cold. Every model predicted a temperature near -373 degrees Fahrenheit. But the actual readings were more than 30 degrees colder. That wasn't just an error, it was a cosmic contradiction. Something, or someone, was draining heat from Pluto's sky in a way no equation could justify. For nearly a decade, the mystery sat unsolved. Until now. Because the James Webb Space Telescope, the most powerful observatory ever built, has finally revealed what's really happening on Pluto. And the truth, as far stranger than anyone imagined. When New Horizons first captured Pluto's surface, scientists expected emptiness. Instead, they found towering mountains made of solid water ice and vast plains of frozen nitrogen stretching hundreds of miles. But above that alien terrain hovered something no one anticipated, a delicate haze, glowing faintly blue. It was thin, yet it reached 300 kilometers above the surface, higher than anyone thought possible for such a small world. It shimmered under sunlight, forming soft layered veils across the sky. But beauty wasn't the strange part. It was the temperature. Pluto's atmosphere was freezing far beyond what nitrogen and methane alone could explain. Scientists recalibrated sensors, reran models and checked data for years. But the math never balanced. Something invisible was stealing heat from Pluto's skies. In 2017, planetary scientist Shi Zhang from the University of California, Santa Cruz, proposed a radical idea, one so unconventional that most dismissed it. What if Pluto's haze wasn't just a passive veil of dust and ice? What if it was doing something active, regulating the planet's temperature itself? According to Zhang, those tiny particles floating high above the surface could absorb ultraviolet light from the distant sun, then re-emit it not as visible light, but as mid-infrared radiation, heat. But instead of warming Pluto, that process might actually cool it, radiating energy into space far more efficiently than gases ever could. In short, Pluto's haze might be acting like a gigantic thermal shield. Most of the scientific community laughed off the idea. But Zhang made a bold prediction. If the theory was correct, Pluto's haze would glow faintly in the mid-infrared spectrum. And only one instrument in existence could possibly detect it: the James Webb Space Telescope's MIRI, the mid-infrared instrument. In May 2023, a team led by Dr. Tanguy Bertrand pointed Webb toward Pluto and its moon Charon. For the first time, Webb's precision allowed scientists to separate the faint heat signatures of the two worlds, something no telescope had ever done before. They scanned Pluto across multiple infrared wavelengths, 15, 18, 21, and 25 microns. The results were staggering. Pluto's infrared glow was stronger than expected, far stronger than could come from its frozen surface alone. Something above it was radiating heat into the void. When the team isolated Pluto's atmosphere, the spectral lines matched Zhang's prediction from 6 years earlier, almost perfectly. The haze wasn't just scattering sunlight, it was glowing, releasing mid-infrared radiation like a slow cosmic exhale. NASA had found the missing energy. The haze wasn't a byproduct, it was the cause. This changed everything. For decades, scientists believed that gases controlled a planet's climate: carbon dioxide warming Venus, methane shaping Titan. But on Pluto, it wasn't gases that ruled. It was solid particles, microscopic tar-like compounds called tholins. Tholins form when ultraviolet light hits methane, triggering reactions that create complex hydrocarbons. As they drift downward, they stack into thin layers of haze, and those layers glow in infrared light, cooling the atmosphere from above. The entire planet functions like a chemical machine, its haze forming, glowing and collapsing with each orbit. Even more astonishing, Webb's data showed that methane escaping from Pluto's atmosphere was falling onto Charon, where sunlight transforms it into the reddish compounds that stain the moon's poles. Pluto, in a sense, is painting its own moon. But what came next was even more unsettling. Webb's observations hinted that this strange haze-driven cooling might not be unique. It might be happening elsewhere, across the solar system, and beyond. The first suspect was Titan, Saturn's largest moon, long known for its dense orange haze and methane-rich atmosphere. When Webb turned toward Titan, it detected the same kind of mid-infrared glow, the same spectral fingerprint seen on Pluto. Titan, too, seemed to be radiating away its energy, almost as if its atmosphere were alive, breathing heat into space. The similarities were uncanny. Scientists began calling Titan and Pluto mirror worlds, both frozen, both wrapped in haze, both governed by chemistry that felt almost organic. Even Neptune's moon Triton, thought to be geologically dead, began showing faint atmospheric emissions, suggesting its nitrogen haze might operate by the same principle. It was as if these distant worlds were whispering to each other across the darkness, following the same hidden rules and a code that binds light, chemistry, and life. When Webb analyzed Pluto's haze in more detail, the surprise deepened. The spectral data revealed that the tholins weren't simple hydrocarbons. They contained nitrogen and oxygen bonds, the same foundational elements found in amino acids. On Earth, similar chemistry once played a role in the dawn of life. Dr. Bertrand described it as prebiotic photochemistry on a planetary scale. In other words, Pluto's haze wasn't just cooling the atmosphere. It was cooking chemistry. Then Webb detected something even stranger, a rhythm, a repeating pattern in how those haze particles absorbed and emitted infrared light. The interval matched Pluto's 6.4-day rotation period almost perfectly. That pattern didn't stop at Pluto. In exoplanetary systems orbiting dim red dwarfs, several worlds, including K2-18b and TOI 700d, showed faint mid-infrared dips that mirrored Pluto's spectral lines. These planets were larger, warmer, yet their atmospheres behaved exactly the same, glowing softly, stabilizing themselves. That stability could mean one thing: habitability. These weren't chaotic, storm-torn worlds. They might be temperate, self-regulating, sustained by the same chemistry that cools Pluto. If true, the very definition of life's cradle would change forever. Life might not need oceans or sunlight. It might begin in the dark, within a haze that protects and nurtures the chemistry of creation. For the first time, scientists began to suspect Pluto wasn't an anomaly. It was a prototype. When Webb's findings reached NASA headquarters, several internal reports quietly disappeared from public databases. One document labeled Atmospheric Anomalies, Pluto and Triton Comparative Study, described non-thermal infrared emissions inconsistent with radiative equilibrium models. In simple terms, Pluto was breaking the rules. The haze seemed to be absorbing energy from unknown sources, not just the sun, and when researchers analyzed the planet's terminator line, the twilight boundary between day and night, they found faint electromagnetic pulses, repeating with uncanny precision. At first, scientists suggested auroras or static discharges, but one note buried deep in the report caught attention. Haze particles exhibit conductive microstructures. Conductive, meaning capable of carrying current. If true, Pluto's sky wasn't just chemical. It was electric, a global circuit of invisible filaments distributing energy around the planet. Suddenly, the question wasn't why Pluto was cold, but what it was doing with all that energy it was shedding into space. Then Webb turned its gaze toward Pluto's night side. No one expected to see anything. This was the farthest, coldest region in our solar system, a realm of eternal shadow. But what Webb found wasn't silence. It was light, faint, rhythmic, structured. At first, scientists thought it was reflected sunlight from Charon, but the geometry didn't fit. The pulses were too regular, too deliberate. They weren't random. They were signals. Webb's mid-infrared detectors recorded a slow, repeating oscillation every 247 seconds. The same pulse frequency Webb had observed months earlier. From deep space, that realization hit like thunder. The same cosmic rhythm, echoing billions of light years away, was now emanating from Pluto. When NASA decomposed the signal, the room fell silent. The pulses weren't continuous, they were encoded. Each carried subtle variations in amplitude that, when mapped mathematically, formed a sequence of ratios: 1,618,314, 2.718, the golden ratio, pi Euler's number, constants that define the very architecture of the universe. It wasn't noise, it was intelligence. NASA's Goddard Space Flight Center classified the data immediately. Officially, the emission was labeled instrumental interference. The report vanished, but a few independent researchers had already downloaded the raw data. When they reprocessed it, they found something even more extraordinary. The pulses were coming from beneath Pluto's surface. Webb's instruments detected faint, electromagnetic echoes bouncing off a layer of highly reflective material, 12 kilometers deep, not rock, not ice, metal down a vast, perfectly spherical structure spanning nearly 1/3 of Pluto's diameter. For decades, scientists believed Pluto was geologically dead. But this changed everything. The planet's crust wasn't silent. It trembled in rhythm with the signal. The pulse wasn't random energy. It was a transmission, repeating the same mathematical language that defines physics, time, and geometry. One researcher whispered, "It's like the planet is trying to speak." NASA's official explanation cited resonant particle scattering. But internally, several scientists resigned after being asked to sign non-disclosure agreements. One leaked note said only this: "Pluto is not what we thought it was. It's something built." Since then, the faint pulsing continues, sometimes growing stronger, sometimes fading, as if aware of being watched. Buried beneath cosmic noise, it waits to be heard again. Each time it returns, the same pattern emerges, the same silent equation written into the fabric of reality. The question now isn't what Pluto is, it's who or what placed it there. So if this story made you question what NASA truly knows about the edge of our solar system, don't look away. Because the next time James Webb turns its gaze toward that frozen world, we may find that the silence of space was never silent at all.